Hello students, in this chapter application of derivatives we are finding so many applications as tangents and normals, rate measure, approximation, monotonic increasing and decreasing, and its application in maxima minima. All these related to the application of derivatives. We have already completed in last video tangents and normal. Now this is the second topic, that is rate measure. Rate, this word we are using in our day-to-day life. Every day we are using this. Suppose you are purchasing 5 pens at the cost of rupees 100. It means cost of each pen is rupees 20. 100 upon 5, this is rupees 20, and this is what we call rate. Or in other words, suppose you are going to purchase vegetables or anything, that will also be frequently used rate. Or somehow suppose you are going somewhere and covering the distance of 100 kilometer in 1 hour, it means the rate at which your lorry is moving is 100 kilometer per hour, and this way we are using in our day-to-day life this word rate. Now actually, as far as we are concerned about the derivatives, suppose there are two variables x and y, and these two variables are related with certain relation, then we can say that for a small increase in x, delta x, there is a small increase in y, and this is delta y. Then we can say that delta y upon delta x is the average rate of change of this, and as limit of delta x tends to 0, this delta y upon delta x is changed into dy by dx, and this is the actual rate. Okay, and these two words we are using frequently while solving the questions. And suppose you are getting any function y fx in such a way that there is another parameter t, then in that case we will find dy by dx as dy by dt upon dx by dt. Now this is the parametric function. Okay, now you can use this in marginal cost and marginal revenue also, that you will study later. Marginal cost and marginal revenue is the separate chapter that you will study later. Now the rate of change in y is equal to dy by dx into rate of change of x, that is delta y is equal to dy by dx into delta x, and this formula will be frequently used. And for solving the questions, we should change the given equation in two variables so that we can find dy by dx. If there is third variable in the form of parametric function, that is different thing, but we will find ultimately dy by dx, and this way we can change that. If in x there is a change in x, then with respect to x, keeping in mind the relation, what is the change in y, and this will be more and more clear whenever we will solve the questions. Now in this question, if the radius of circle increases from 3 to 3.01 centimeter, find the increase in area. Now keeping in mind the concepts that stated just now, you can see there are two variables in this question, that is area and radius. In place of that formula, we were getting variables x and y. Here we are using the variable a for area and r for radius. And second thing, which is increasing, both the a and r is related with certain relation, that is a is equal to pi r square. Now what we have to find out, radius of circle increases. This is increases. Previously the radius of the circle is 3 centimeter, then this is increased by 0.01 centimeter. Then what effect on the area? This is our question. In all the questions we will study that keeping the relation between two variables, if we change one variable, then how can this affect to other variable? Now you can see here r is equal to 3, then delta r is 0.01, and we know the relation between area and radius of the circle, that is area is equal to pi r square. Then differentiating with respect to r, I've already told you when discussing the concepts, that is we will use two variables. Now here we can see the variables a and r, two variables, and so that we can differentiate very easily with respect to this, because dA upon dr is equal to 2 pi r, at r is equal to 3, this value comes out 6 pi. And what is our formula? We just studied, that is rate of change of this, that is change in y is equal to dA by dy by dx, in at that point change in x. Using that formula, change in area will get when we change in the radius. Delta A is equal to dA by dr at r is equal to 3 delta r. Putting the values we are getting, this will change in the area 0.06 pi centimeter square. Now next question. A balloon contains a certain mass of gas whose volume is V centimeter cube and whose pressure is P Newton per centimeter square, where small p and capital V, pressure and volume, obey the law PV is equal to 1000, and this is obvious that this is the Boyle's law. If the volume increases at the rate of this, then find the rate of change of pressure when the initial volume is given 40. Now again we are given here that rate of change of volume is 50 centimeter per minute. Now the initial volume is given this, at this rate the volume is changing with respect to time. Now here there is third variable time in between pressure and volume, and that is why we'll differentiate pressure with respect to y, v, and then again write in this form dp by dt is equal to minus 1000 upon v square dv upon dt. Now you can see the sign is changing, this is negative sign, it means this decreases, because you can see P is proportional to 1 upon V. As volume will increase, pressure will decrease. As volume will decrease, pressure will increase, and that is both the pressure and volume are inversely proportionate to one another. And this is happening by solving the question. We are getting minus sign, putting the values, this is coming minus 31 over 1 upon 4 Newton centimeter square per minute, which is decreasing. You must write in answer increasing or decreasing. Okay. Now next question. The volume of a cube is increasing at a constant rate. Volume is increasing at a constant rate. See here, dV by dt is equal to constant. With this line this is given, and which is increasing. Prove that the surface area is increases inversely with the length of the edge. Means surface area of cube is 6a square. This we have to prove. Means which is going to be proved, that should be differentiated with respect to another variable. But here one more variable, time, because constant rate we are getting dV by dt, and then we'll divide by dt in both sides, and so that we can substitute the value. First of all, volume of cube is equal to a cube, and this will be differentiated with respect to the side, and then divided by dt, so that we can substitute the value of dV by dt as k here, and for getting the value of dA by dt in terms of k and a, and then writing the formula of surface area of cube, we know that 6a square, where a is the side of the cube, ds by dt is equal to 12a dA by dt. Then substituting the value dA by dt, from this we can get k upon a, since k is constant, and so ds upon dt can be written as 1 upon a, means this is proportional to 1 upon a, and this is what we have to prove, that surface increases varies inversely as the length of the edge. And here you can see this surface area varies inversely as the length of the edge. This is all about this question. Now next question. A man 1.6 meter high walks at the rate of 50 meter per minute away from a lamp which is 4 meter above the ground. How fast the man's shadow is lengthening? Now here you can see this is the lamp post and this is the man, and this is given 4 meter, and then 4 meter is this one lamp, and man's length is 1.6 meter, and once lamp is here, then the shadow will be on this side because lamp is at the back, and then as the man is walking, how fast this shadow with the point N is moving. Now for this question we will use the concept of similarity that we studied in class 10, and first draw the figure. After drawing the figure we can see that these two triangles are similar triangle. Now you can see here that tip of the shadow, that is N, is at a distance x plus y from the lamp post, and that is why rate of change of this tip of shadow will be equal to dx by dt plus dy by dt. From these two triangles, this angle and this angle equal because of being 90 degree, and this angle is common, so these two triangles are similar, and if two triangles are similar, then the ratio of their corresponding sides will be equal. Okay, now after substituting the value, this is coming 4 upon x plus y is equal to 1.6 upon x. By cross multiplication we are getting x is equal to 2 by 3 y. Now differentiating with respect to t, because we are given that this is moving with respect to t as 50, and dx by dt we have to find out. So differentiating x is equal to 2 by 3 y with respect to t, we can write dx by dt is equal to 2 by 3 dy by dt. Substituting the value dy by dt is equal to 50, we are getting 33 whole 1 upon 3 meter per minute, for which the man's shadow is lengthening. Now next question. Water is dripping out from a conical funnel. The funnel is of conical, means this will be like this cone, and at a uniform rate of 2 centimeter cube per second, means rate of change of volume of water dripping out from this is 2 centimeter cube per second. dV by dt is coming out. This is already given. Now next, through the tiny hole at the vertex of the bottom, when slant height of the water is 4 centimeter, find the rate of decrease of slant height of water given that vertical angle of the funnel is 60 degree. Now first of all we'll draw the figure. Since we are given vertical angle is 60 degree, so semi-vertical angle will be taken as 30 degree in this cone. Now we know the volume of this cone is 1 by 3 pi r square h, and then in this one, since this is right circular cone, and then this angle is 90 degree, and so in this right angle triangle, this is taken as slant height, which is already given 4, will substitute afterwards. Then in this right angle triangle, AB is equal to L sine theta perpendicular upon hypotenuse and base upon hypotenuse, that is OA is equal to L cos 30. Means we are getting AB and OA in this way, and this is AB is R and this OA is H, height of the cone or conical funnel. Now write the formula. V, volume of the cone, is 1 by 3 pi r square h. Then substituting the value of R from here, we are getting L sine 30 and then L cos 30, and then we are getting 1 by 3 pi L cube root 3 by 8. Now differentiating with respect to L, because in all the questions we'll try to keep two variables so that we can differentiate with respect to another variable, and volume is changing, we have to find out the rate of decrease of slant height, and that is why we'll differentiate with respect to this dV by dl, and we are getting 1 by 3 pi root 38 into 3L square. Now dividing both sides by dt, we are getting dl by dt is equal to pi upon root 3 after substituting the value of dv by dt in this. Okay, and this is 1 upon pi root 3 is centimeter per second is the answer for this question. And this is all about this topic, rate measure. Now you can download few more good questions from my website given in the description. Thank you.